In the last few videos, I've been showing how to divide polynomials using factors, roots, that we already know or guessed using a graph or intuitively. Here we have another polynomial, no graph, no hints. Let's do that guessing method that I did in that first video and show how it doesn't work. I'm not going to go on my whole spiel again about blah, 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 blah. But yeah, let's just factor something out here. Just guess. So we have minus 45. I'm going to assume that one of our factors is minus 1, like I did way back in the first video. So if the factor is x minus 1, then the 0 is going to be 1. So let's do this synthetic division. So 1 in the box, 12, 44, 9, 45. Bring down the 12. 1 times 12, boom, 56. Cool. Yeah, it's just 1, so very evenly. 9 plus 56 is going to be, I'm having a brain fart, 65. 1 times 65 is going to be 65 again. Subtract through, we get positive 20. And we have a problem. Because in all our other videos, our remainders were 0. But now, here we have our remainder, constant, x, and then our x squared term. We have 20 as our remainder. Now, this tells us that x minus 1 is not a factor. If this remainder was 0, then that would mean that we can take it out cleanly, meaning that there is no remainder and that it is a root of that polynomial. But here, what? What do we do with that? How can we write this as an actual expression and not just leaving it as, you know, R20? If you don't remember, maybe you do. But, you know, way back in elementary school, when they first teach you long division and you work with remainders, before they teach you how to annex a 0, find decimals, they just tell you, or they told me, I guess, schools are different, you can just leave it as R, whatever you have left over, remainder of 20. But no, we can't do that. This is a polynomial. We need to do math with that. So we can't just leave it like this. So let's think here of what it might look like. I'm gonna move further down this way so I have more space. Let's think, if we have a function, I'm not gonna use this one, I'm gonna start using some other variables here just to show the process. Let's use a cubic, for example. If we have just any cubic polynomial, x cubed plus x squared plus x plus c, our constant, if we divide that by, you know, a linear polynomial, this is, you know, how we end up doing all this. But you see, our constant is what turns into our remainder. What happens there? Let's see, we can break this up. This is the same thing as x cubed over x plus b plus x squared over x plus b plus x over x plus b plus c over x plus b. Now, this whole process here, we're going down a degree. We're taking an x out. That's why we have a cubic, and then we end up with a quadratic. That's why. So this whole process, I don't really care what the real solution is, right? It can be anything. We can just say that when you're done with this, after you take the x plus b out, you get just an x squared term after you take it out. It doesn't have to be clean. Whatever it is, it's going to be an x squared. The same thing here. You are just going to get an x. You're taking an x out. Now here we just have the x. So that leaves us with a constant. No x is attached. But what does that tell us here? We're left with something that doesn't even have a degree, and we're taking an x out of it. Now clearly, the x does not come cleanly out of this. That's why we have a remainder in the first place. So since it doesn't come cleanly out of it, we can say that this is still the remainder, right? It's not the constant anymore. This is our constant. The remainder over x, that's not an x, x plus b. It didn't come out cleanly, that's why we still include it there. So, using this, let's try to rewrite this in a way that, you know, we can make sense of this remainder. So, what we took out was x minus 1. We took out x minus 1, so let's just have that on the outside. Now on the inside, we're going to have 12x squared plus 56x plus 65. That's closed. That is the term. But remember, we have this 20 right here. Since this is our remainder, we will write this as 20 over what we divided by our divisor. So, when you get a remainder that is not 0, you can write it like this. Coolio? Yeah. Now, even if we got a 0, you could rewrite this like this, but then you would get 0 over x minus 1, which is just 0, right? If the numerator is 0, 0 divided by whatever is 0. So that's why when it goes out cleanly, you are just left with your factor and the quotient. Isn't that amazing? Yeah, I think so.